Good day, I'll be presenting my analog and digital electronics project on filters. Filters in electronics are circuits that allow signals with specific frequency range to pass through while preventing other signals outside that frequency range. Filters are commonly used in power supplies, voice and data communications, and audio electronics. The function of filters is to eliminate background noise, reduce ripple in power supplies, radio tuning, and amplify or attenuate audio signals. The objective of this project is to design and construct a filter circuit that accepts signal having frequency range from 0 Hz to 1 kHz only. The filter circuit is an active bandpass filter, and this is the schematic diagram. This is the hardware of the circuit on breadboard. From the simulation results, when the operating frequency equals cutoff frequency, the gain is 3 dB. The bandwidth of the filter is 999 Hz. The center frequency is 31.6 Hz. The quality factor is 0.032, which is a wideband filter, and the gain is 3 dB. The filter has a frequency response of a Butterworth filter as it has a smooth passband and has a magnitude of a 3 dB roll-off after the cutoff frequency point. The hardware of the filter circuit. The power supply, which is set at 5 volts. The function generator is set to deliver a signal of 500 Hz frequency. The oscilloscope displays a Vout reading of 8.08 volts. The frequency is increased to 600 Hz. The Vout reading is now 7.84 volts. Frequency is now set to 1 kHz. Vout reading on the oscilloscope is 7.12 volts. An active bandpass filter was designed and constructed to accept signals having frequency range from 0 Hz to 1 kHz only. The filter has a frequency response of a Butterworth filter with a smooth passband and has a magnitude of 3 dB drop off to 0 after the cutoff frequency point. Laboratory simulation of the hardware circuit confirms the filter functions according to specifications. This is the end of my project presentation. Thank you.